There are certain moments when even a paralytic feature like myself has memory problems. When I spoke about digital amnesia, then it's a situation in which we think that we have data and that we have cared for the data, and when we really need the data, then we are at a loss. How large is a bit which is stored? As time moves forward, it becomes smaller and smaller. And data bits, the decrease of data bits doesn't mean that the sizes of our equipment go down to infinity, but then rather that we want to squeeze more data in the same area. And if there is some problem, then there is a mechanical or electronic damage, then even more and more data will be lost. So with the increase of writing density or data density, the level of severity of data loss is increasing. Data may be small, but may be very valuable, may be important, may be vulnerable. How much does it cost for us to regenerate it? So these are also properties of data. And our source of security is that we try to do our best. We save our data, backup, restore, we put it into objective code, machine code, and then we think that we did everything possible. And then these data will be available whenever we want to use them. But what it looked like in the older time and what changed. The size of bit is shown in this picture. This is the ENIAC computer for trajectory calculation. No, there was even an earlier machine called Colossus. That's not the ENIAC, but Colossus. Alan Turing was its creator, prepared in 43-44 during the war, with Enigma and Cohen's encryption cracking. It was so secret, it was declared confidential for 60 years. It was a stored program unit, so digital amnesia appeared together with it, because whatever we store, we can lose. In Colossus, one electronic tube, it's more than one tube, one column represented one bit. There were two bistable, kind of flip-flop tubes, and there were some fuses, that was huge for storing one bit, but it was very quick at that time, and it was very effective at its time. And that was the reason why it was classified for 60 years, and everyone remembered that ENIAC was the first instead of Colossus. ENIAC was much smaller. One bit was over two tubes, which stored one bit. But there are no... This is John von Neumann next to ENIAC. Let's salute to Neumann. And he played a very important part in designing ENIAC. And there was a company, a giant that has arrived, IBM, International Business Machine. And this window is not for running Windows, but contained electronic tubes. There was a double tube representing one bit, one tube. You can see the size difference mechanically, but still we speak about performances of kilowatts. But in 48 that was a very good vintage year, because that was the invention of the transistor, and in 53 the first commercial transistor appeared, which is called a needle transistor, with huge amplification, amplification coefficients of 10, and then these were the discrete transistor machine. One bit stored in transistor, it is taken from an ITP or IBM machine, and this is the display utin. And then probably you remember these old radios with the cat eye, the green cat eye. with which you could tune the radio, this green light of the very old radios. And then these cat eyes, the green cat eyes were there, and then you could see the values of the bits. In Hungary, Terta, which was a telephone factory, produced the first transistors, inverters, gates, separators, flip-flops can be built from gates. They had 3 types of supply voltage, and it could even work at 100 kilohertz, which was very high speed at that time. Robotron, East Germany, thick layer hybrid circuits. They built computers from NAND gates. And this is what the East German computer looked like from the inside. These are the panels, the boards. And since this machine was extremely quick, they really had to have short wiring because of the high frequency, and it could tolerate 1 megahertz of clock signal. And then the 4 times 2 input NAND gates appeared. Integrated circuits appeared. A simple integrated circuit, which is still in commercial traffic, 4 times 2 input NAND gates, normal and military type of design, and this military is as small as the SMT circuits today. And then data should be read in, for which we had the punch tape. Punch tape, 1 hole is 1 bit. Unfortunately, in practice, I saw that the manager was standing next to the reader. He checked the tape and improved the whole thing by using the scotch tape, and then he used a conductor's puncher to punch a new hole, and then the scotch tape was actually got stuck in the computer. That's a punched card. In the IBM time, much more intelligent things. How many bytes could be stored on a 256, I think? Annyi volt, nem annyi volt. Maybe not. I don't know what the correct number was. And there was another operation.
Ugyanis nem karakteres, tetszőleges hexadecimal.
You could also include hexadecimal values, which were not characters. In the mainframe days, you could use that for IPR, that is to boot up the system. You could use a punch card to do that. The ferrite storage matrix was the first one ever mass-produced. There were ferrite rings, 2.5D, 3D were the structure. That's the forget type storage, because when you read it, it will forget the content. So the ferrite storage device had 2 stages of utilization. At the first stage, I had access to the information and I could proceed and process it, but there was a write back period when the data read had to be written back. There was a transluxor, non-forgetful type ferrite, and logical operations could also be carried out. This Luxor ferrite comes from the early 50s, the first metro line of Budapest that was never built. That's about 1 centimeter in diameter. And then the semiconductors came for interim storage. One was the Commodore-based 16 kilobit, and then the 64 kilobit version. And then the storage areas began to decline in size. these were dynamic storage devices, so even in the presence of the feed or power supply, they needed refresh pulses, and people who knew mainframes found this very unusual because they were used to the idea that they could halt the machine and read the storage areas. So static storage blocks appeared. That's from the mid-70s, produced by Videoton. That's 2 kilobytes of static RAM. That's the VBT series storage area. And this one is a Hungarian development, a project, a data co-op. The ferrite storage blocks were replaced by these 16K storage blocks. And of course, we now find EEPROMs natural for BIOS. That was the next step. Fixed data storage blocks appeared. This one is a well-known 32 kilobit version, and 5 years before, 32 bits was the size of a storage block here on the left. And devices shrank in size. Storage areas became smaller, processors, CPUs became smaller, and then multi-purpose devices came along, and you could gain a lot using them, and you could lose a lot if you lost them. This one is based on a continuous power supply, and it has a 16 meg RAM portion. You could include any data, and the 16 megs for EEPROM, a complete static website, would fit inside this. And if you plug that onto a 9-volt battery and hide that somewhere in the machine, the network people will take a long time identifying and detecting its location. Now, at the same time as IBM's 360 series hit the market, lots of new devices came alongside. The magnetic drum, the data cell, which is like today's bank cards. It had those big magnetizable strips, and number 21, magnetizable disk. It had a capacity of 7.26 megabytes, and ferrite was still sold for back-end storage. Interestingly, when you switched it off at the end of a process, you could come back and in 3 days power it up again, and all the data was there. Now, this is the first IBM major storage magnetic disk. It's the first magnetic disk storage device. That's 7.25 megabytes worth of data storage. That was the first IBM data storage device, and it had to be checked all the time because we had what we called the disk pestilence, which meant a small contaminant which would be smeared onto the disk by the head, and then you could in minutes destroy the heads in the same position for lots and lots of disks. I have a good old friend who has a printing company in Austria, and one day I saw a pen drive and 1 meter's worth of pony paper, and on the other side of the machinery out comes a book in as many copies as ordered. And Printing Unchained was the title of this book, and it provides a summary of 50 years of printing. Now, I'll give you a copy of this book if you can tell me why one needed a ball pen in order to maintain the disk units. Because you could use that to remove it from the drum. Yes, you'll get the book. So in order to check the cleanness of the surface, you had to remove it from the casing, and you had to wind up the appropriate locking mechanism, and it came out.
Tehát itt van a
So here's 2311, the disc pack, which is photographed here, and that's a roll of Scotch tape at the top of it. So that's a spool of Scotch tape there. And an accessory is this ring. What is the ring, and what does it do? How does it work? When do you have to apply it, and when do you remove it? Yes, correct. Off mic. Sorry, no translation possible. And as machine sizes shrank, so you don't like having to lift this 12+ kilo package all the time, so storage units became smaller and smaller. Floppy diskettes shrank like your laundry. Single-sided, single density. What's the capacity? Who can tell me? 128. Yes, correct. You'll get one of those. While this spool of tape stored about 7 megabytes in DLT, nowadays commercially available devices store 1 terabytes of data. So if I lost this small pool, or if in the tram it got magnetized by a power source, I lost 7 megabytes worth of data. And if I place DLT in such a place, I would lose 1 terabytes worth of information. So that's digital amnesia. We also had storage media for back-end storage, cheap devices that don't forget data. Csaba, any more prizes to give away? An HP notepad will go to the person who can tell me what this is. This is a storage unit. 1 megabit is 1 megabyte is the capacity. What is the nature of the storage device? It's bubble-based. Bubble storage. So that's a bubble memory, because it was developed because military personnel have these crazy ideas that even if there's a nuclear attack, data should not be erased. And this one is pretty insensitive to radiation or outside influences. So in military establishments it was commonplace, but unfortunately there hardly is any device around, not at least in Europe, that can read it. And we recently had news that Secret Service tapes should be read and data should be retrieved, but there are no readers, because IBM ASR, SETMB 5017 and the like were quite standard equipment. and you found them in all the corner pubs, but they are forgotten, and people forgot to convert the data media when they migrate their system to a new medium, and regeneration, rewriting should take place every now and then, or retain units, as have the Americans. The analog MPEX data tapes of the moon landing were stored, but they also stored the reading devices, so if they wanted to go back and check, they should be able to do so. And of course, you can lose a lot of data if a large capacity machine fails, because if one instruction only deletes 80 bytes, it's not as elegant as being able to delete 1 terabyte. Terabytes, that is. And look at the tape devices. Here's a magnetic tape device. The tape is standing still, and the vacuum chamber prepares the tape, and then the feeding mechanism gets an impulse, and it speeds up. And then writing begins, 80 bytes, a few millimeters, and then it starts to break and will stop. The start-stop span is about 15 millimeters. So 30 to 33 millimeters is the actual processed tape length, and about 15 millimeters is the useful version, useful part. So if one block fails, then we've lost 80 to 100 bytes. But if in streaming mode the tape fails, breaks, you can kiss goodbye to it, because the servo band is damaged, and in the case of the IBM tape devices, 80% of the tape surface is a power serve area, and if that fails, then all of 1 terabyte is lost. A similar risk is entailed by the following, when we say that what used to be done by mainframes could now easily be done by a mid-range computer. And you trade down by one category. You have a mainframe running MVS and VSAM and DB2. And we have nice backups stored, filed away in a secondary data storage unit somewhere. And you push out this unit and bring in the next new IBM unit. And we want to start using it. Now, there's a double pitfall in this. First of all, if you had a backup, you can't recover, because MVS and VSAM and MS management at the physical layer means 2 overlapping file systems. And if I were to restore my data in my own environment, then VSAM master catalog is the source based on which I can find the original DB2 database. Now, if I bring it into a strange new system, in the contents there will only be one VSAM file, but you won't be able to make sense of the structure. So I have a backup, and yet I don't. The other option is to export the data. The description tables go out there very nicely, sequentially, and I'll be able to interpret that. But beyond that point, I've lost all my protection. So somebody who gets the tape gets all the data. It's a case of having to decide where you want it to hurt. Let's move on. One more step down. CDs. Now you archive your photos or burn your downloaded files and even movies to the CD. Now you purchase a cheap CD, you burn your content, and in 3 years, you go back and you won't find any information. And instead of $15 you get CDs for $1.50. Well, on paper, data should last 200 years based on the aging tests. It's likely to last 50 years if you extrapolate. So if you want to use CDs for archiving, it may be worthwhile to pay a higher price. Here's this wonderful device. It was very popular about 30 years ago. The interesting point is that it has two battery packs. One is for normal operation, and the other is a backup, which will keep alive the memory. And if you carefully replace the batteries, you can be sure, you suppose, that your data won't be lost. Yes, indeed, but it has a rubber keyboard, and after about 15 years, the rubber juice switches it on every now and then. So first the normal battery goes flat, and then the backup battery, and you've lost your data. And the other thing you hate losing is your SIM card of the cell phone. So there is one solution. This SIM card reader and archiving unit will read the information and store it for you in static RAM, not in flash memory. And if the battery goes flat, you no longer have the backup, and you will have lost your SIM card data. So these are the small tricks that lead to loss of data, and there are bigger problems as well. There may be a fire destroying the data in a data center or storage area. Then, if you want to be absolutely sure, then you need to archive data on two different kinds of medium and store them in two different places. Why do I need the two different media, that is? Because let's suppose you have a tape, and you save that onto two different media. Let's say the tape unit dies and the tape head becomes defective, and it will scratch the tape. It's a read error. You call the storage facility and say, guys, I have a problem, bring the backup because I can't read the primary data source. And I mount the new tape, and the head is going to scratch it all along the same way. And that's why in the 1981 Data Protection Act, which has been repealed since then, there was a provision that backups must use two different kinds of medium. I'd like to show you this other interesting point. I'm not giving it away. What's the size of a bit? We didn't just have electronic computers, we also have electromechanic computers. This is one electromechanic bit. It's a relay. It's a mechanical relay which retains a switching position of 1 or 0. Konrad Zuse actually managed to build a computer out of these, and he succeeded, but it was a huge machine. That's all I wanted to say for the time being. Any questions or comments?
Szépen, hogy ajándékot fogadj el tőlünk, ha már nagyon sok annyit adtál nekünk.